see the effect of perhaps sheep feces or urine on nitrous oxide production and CO2 production. And then, as I say, at a programmed sequence of timing, each of these canopers will be closed in turn and a measurement taken. You couldn't theoretically take them all at once. Ideally, you want to go round them all in a sequence. That's the way these things would work. But I think there's roughly, every hour, I think you can take a sample from each of the chambers, something like that. So we've been very lucky. This is expensive equipment. We've only been able to buy 2 sets of this. But the idea is that you take them out to the fields, as I say, and if you've had a farm-scale operation that's gone on, like you've just applied fertiliser to the field, for instance, you can go out, set these things out around the field, and they've got long cables, so they can stretch out a long way around the field, and then take as many measurements as you like over a period of time, so that we can really start to capture some information about both spatial and temporal changes in the gaseous flux. So with this equipment you start to understand what's happening at a temporal as well as a spatial scale. We'd like to buy some more, but I don't think we're going to get the money for that. Normally these sensors are being used mostly for carbon dioxide using this bit of kit, but we've managed to incorporate the use of the nitrous oxide analyzer with it. It's something that's quite novel that we've been able to develop because it hasn't been done before. So we can measure these two gases together.
So if you look at the photos going round, okay, then it shows you that this thing rotating sideways. The whole point about monitoring terrestrial gas emission is obviously you can't just sit a sampler over the soil with a gas takeoff, because then the sampler itself is perturbing the soil, it's stopping rain getting to it. Okay, so you have to have a system where normally the soil thinks it's just under natural conditions, which is with this thing rotated around. This base plate is then sunk into a mounting. Yeah. Then, so you can see on these photographs the thing rotated round, it rotates back. So under here is just an open ring. Okay, so it rotates around, rotates back, sits itself down, takes the gas sample. Okay, some of you saw that on Country File a couple of weeks back. Wyson Wood, Oxford University. They said they're only monitoring CO2, which on its own is just giving you the general respiration level of the soil. But if you're clever and measure nitrous oxide as well, what is happening in Northwick, then that's much more exciting because it's telling you what the denitrification processes are. Okay. Okay.
Any questions about this equipment? No? All understand it? Understand how it works?
The other thing again is to remember about scale, that if you've just got one of these things, then you hope that you're not in a, you haven't just chosen a bit of soil where you might have excessive nitrous oxide production or something, because it is all patchy. That's the problem. Okay, and again, ideally you'd have a whole set of these going through. So the multiplexer is just like a sort of switching device. Okay, just before you go out, just come and have a look at it. What it does is it essentially switches between channels into a single analyzer. Okay, so it's like a sort of rotary switch, if you like.
Please don't touch it. It's not plugged in, so you won't get a shock. In a minute we'll be moving over to have a look at another way of looking at gas from soil, which is very much in a system that we can manipulate very, very finely the various factors that you might be interested in. That's the Dennis system, you've already heard it mentioned this morning. So we'll just be moving from a field-based system back to a laboratory-based system. Okay, just to get it in context. Coming back into the lab on a smaller scale again. Right, so we'll come come round and have a look round if you haven't seen it. It's a shame I couldn't show it working because it's quite nice when it's working. Can't find to take a picture for you. Please take charge. Well, it's a chamber. It's a dynamic chamber. You can have a static chamber. This way you can